Okay, so hi everyone. My name's Justin. I am the Weber State Energy Manager, and normally I visit classes to talk about energy, to talk about sustainability, what Weber State is doing, how we're paying for it, what its impacts are, and how it affects you. Um, Given the current situation, I am not on campus. Our buildings are closed to the public. Nobody that doesn't have an office is allowed into buildings, and sometimes not even that. By the time you have seen this video, that may or may not have changed. I do suspect it'll get worse before it gets better. I'm recording this on March 23rd, but I've been working home for about a week. But I wanted to record a video. This will be a resource for the future and also to provide some support to our faculty that are wanting this sort of material for this online distance learning model. So with that, I will dive right in. I will include my contact information at the end of this slide deck, because normally when I give this sort of talk or give a tour like this, there's lots of questions, there's lots of things that pop up. There's usually one or two people in every class that are quite interested in this kind of stuff. I'd encourage you to reach out to me. Our volunteer opportunities are changing a little bit, obviously, but as things get back to normal, there's a lot of ways to get involved, and honestly, lots of prospective employment, particularly in the energy realm. Weber's actually getting a new energy engineering program going. I can help you with if you're interested in that. So with that, I'm going to dive into this. I'm hoping this will be maybe 30 minutes, maybe 40. I'm not going to go for a full in-depth presentation. So here we go. We're going to go back in time to start this off. Last time we had a huge economic dip was right around the time when Weber became interested in pursuing some of these environmental initiatives. Okay, so our president at the time, her name is Ann Milner. She's now a state senator. She is also still faculty here. Signed what is called the ACUPCC. That's the American College and University President's Climate Commitment. We signed that in 2007, and we said, hey, we want to become carbon neutral by 2050. Great. Right? Great commitment. 800 or so universities have done this to this point. At the time, nobody really knew how we were going to approach this problem. Nobody really knew what this meant in terms of infrastructure, staffing, capital expenditure, utility investment, and all of that. I will explain to you our process as we go forward. It really fell to the facilities management group. Now, I am part of the facilities management group, and I am in particular, I'm within the part of facilities that is in charge of maintaining and operating buildings. Okay. Now I have a counterpart, Jennifer Bodine, who is our sustainability manager. In 2008, actually, I'm not sure if she was here in 2008, but in 2008, Weber State conducted its first greenhouse gas inventory. So basically, what a greenhouse gas inventory is an accounting of where emissions are coming from and how much of those emissions there are. Okay, so if you think about the operations of a university, some of these are very obvious, right? We have a heat plant on campus that burns a lot of natural gas. We have fleet vehicles. We have electricity. All right, some of them are not so obvious. One in particular that a lot of people don't think of when they think of carbon emissions is carbon emissions due to waste. Carbon emissions can come from waste due to the biodegrading of organic matter in the landfill that releases methane, right? Well, it's not a huge portion of our emissions portfolio. It is there. And the whole idea here was, hey, we need to know what we're going after before we start biting the elephant, one bite eating the elephant one bite at a time. So in 2009, we adopted our climate action plan. This is published on our website, weber.edu/sustainability. We're actually in the process of updating it right now. And what this does is it takes our emissions, it divides them into three scopes, things we do on campus, things we do off campus, and then things that are kind of directly related to campus but we don't control. And it laid out a plan for how we're going to address those things. So in 2010, we created the Energy and Sustainability Office. That's where I work. I have an electrician who works for me. I have a utility analyst. I also supervise our building automation team. We have a number of sustainability people who work on things like food and other things that I'll talk about as I go forward. But that's really where things the ball got started rolling with regards to sustainability at Weber State. You had a strong push for carbon neutrality from the administration. That was a directive to facilities management. And then at the same time, on the faculty side, you had the establishment of what's called the Environmental Issues Committee, and they pushed a lot of great things through as well. It was about 10 years ago. In 2015, we created an academic sustainability office called SPARK. And then in 2019, we're proud to have achieved STARS Silver. STARS is just a rating system that looks holistically at the campus in terms of operations, curriculum, the built environment, and gives you a rating. So we are now STARS Silver, which we were very proud of. We kind of lingered on bronze for a long time, so we are very happy to get there. Long story short for this slide, the goal for Weber State is to become carbon neutral by 2050. If you look at the Intergovernmental Panel on Climate Change, you look at their recommendations. If as a society we get to carbon neutral by 2050, we can avert some or the worst of the damage that will result from climate change. Now, these models are changing over time as they get better and as things continue to accelerate. But we felt that that's a pretty reasonable goal, both in terms of the dire nature of the climate crisis, which is obviously taking a back seat right now, and in terms of what it takes to actually get to carbon neutral. So I'm going to touch on each of these topics as we go forward. When I say the word sustainability, generally what we mean is not compromising the future for the present. Okay, you can think of it as the same way prudent financial practices like personal finance, not spending more money than you make, not using more resources than the earth can regenerate. Okay, and this applies to energy, it applies to climate, air quality, transportation. Water is a big topic that is coming in Utah. Our population is supposed to double by 2050. Our water supply will not be doubling. So there's going to be some tough conversations there. Waste, are we recycling? Are we reducing waste? I'm sure many of you are familiar with the plastic epidemic that's kind of besieging the globe as we speak, things like the Great Pacific Garbage Patch. Microplastics, all of these things. Food is another big area, as we're getting into agriculture, industrial agriculture, non-regenerative practices, the idea of food deserts, accessibility of food. These are all very big questions. My particular expertise is in the energy and climate, a little bit in air quality and transportation, but I'm professionally, I'm very focused on energy and Weber State's contribution to climate change. In particular, I mentioned those three scopes. My responsibility is what's happening due to our buildings, right? In general, most estimates say with regards to air quality and climate change, about 30% of the problem is our buildings. 30%, right? And so commercial buildings are very different from residential buildings, but my job is to make sure our buildings are efficient, that they're operating properly, and that we're minimizing their environmental impact. So how do I do that? It's been interesting. I've been in this job for about 4 years. I'm actually going to take a quick break and make sure that my recording is actually working. All right, for you that was instantaneous. For me it was about 15 seconds making sure my recording was working and my slides were actually up. So one of the things that I have worked on as Weber State's energy manager is telling the story and taking these complex engineering principles of energy, mechanical engineering, pumps, and so forth, and breaking it down so it's easily understandable for somebody that doesn't have an engineering background, for somebody that's not a total geek like me, right? So the first point in our 4-point plan that we've built here for our outreach efforts is efficiency. Okay, so the idea there is very simple. The idea is just that if we use less energy, the impact will be lower and it will be easier to get to carbon neutral. Okay, and the good news is there's a lot of financial return in efficiency. This is a big push across the entire industry of energy management and energy efficiency. I'll touch more on that a little bit further on in the presentation. The second point, and this is somewhere where Weber State is very unique. In fact, on Friday, we are presenting at an Association of Energy Engineers meeting on this topic because we are the leading edge of the sword. We are electrifying our campus. We are displacing the direct combustion of fossil fuels and replacing it with electrified technologies. Okay. If I do that, so I'm reducing the energy that I use, I'm electrifying the end use of that energy. Now the next step is to source that energy renewably. Okay, so I minimize, I electrify, I source renewably. That's what we're doing with our infrastructure. Once I source energy renewably, the carbon footprint goes away. Okay, and there's ways to do that make economic sense for the university. We're not just talking about greenwashing. We're not talking about the latest trendy thing to do. There are a lot of beneficial underlying economics to these efforts. So those first 3 points, efficiency, electrification, renewable sourcing, that's what's happening on the infrastructure side, okay? The fourth piece, reinvestment of savings, this is another place where Weber State is very unique, okay? Every dollar we save on our energy bills gets reinvested into more energy projects, okay? And I'll explain a little bit later in detail what that means. All right, so let's talk about efficiency. With the advancement of technology basically across the board, the efficiency space has made so much progress across the country that, for example, our local utility, Rocky Mountain Power, is actually giving money to companies who pursue efficiency projects because it reduced their operating costs, and it reduces their operational costs to the point that they're not planning on building any new power plants, right? This is what they're doing instead of capital investment, is encouraging their customers to become more efficient. Dominion is doing the same thing. So to give you an idea of the scale of what we're looking at Weber State with regards to energy consumption, on our baseline, which is our business as usual scenario, okay, so we averaged our energy consumption per square foot from over a 3-year period from 2007 to 2009. That's what we compare to. Okay, at the time, we were consuming about 35 million kilowatt hours per year and about 200,000 decatherms of natural gas. Okay, so 35 million, 200,000 electricity, natural gas. To put that into perspective, on my home in a bad year, and I've got about a 2,500 square foot home, we consume about, I'm doing the math in my head, maybe 10,000 kilowatt hours. No, not even. No, about 10,000. I think that's a reasonable estimate for an energy consuming home. And I'm probably in the realm of 50 decatherms of natural gas. Okay. So 3 million square feet, all of our different campuses, Davis, Morgan, the West Center. Obviously, Ogden is the largest. Ogden is just shy of 2 million square feet. We have a lot of major buildings. We also have a lot of diversity in the types of spaces that we serve. And that plays a role in this. But what are we doing in terms of efficiency? I'm not sure if you'll be able to see my mouse or not. This top left picture is a picture of our steam distribution tunnels. So there's 1.5 miles of steam distribution that goes underneath the campus. One of the first big pushes we made in terms of energy improvements to campus was getting leaks under control, re-insulating these lines. You can see these lines are all insulated, and we actually turn our steam system off during the summer, which is very contrary to typical engineering and management practices in the HVAC world. Okay, when I tell people we shut down our steam plant during the summer, people look at me funny. Now, we had to do a few things. We had to install some auxiliary equipment for places that still do need heat. But the take home is we save about $400,000 a year just from our steam shutdown in the summer. $400,000 a year. Okay. Now the insulation we put on this stuff, it's pretty cool. It's called aerogel. For every centimeter, it has an R value of 10, which is astronomically high. So we re-insulated all of these lines, and we routinely inspect steam traps and expansion joints and all of that kind of stuff for leaks. That's one of our big pushes. One of the other big pushes that we're doing that makes us a little bit unique is what we're doing with lighting. So all of our lighting is eventually going to be LED. I have an electrician who works on my team. His job is to upgrade the campus to LED, and his two current projects that he's kind of bouncing back and forth between are the gym and the D2 building. So LEDs are up to 90% more efficient than traditional technologies. 90%. I have projects that have gone, per fixture from 400 watts to 40 watts. Okay, so there's a little bit more upfront cost, but the money that you save during the operation of the fixture more than makes up for it. Most of my energy lighting projects pay for themselves in 6 to 8 years. Okay, LEDs also last much longer, which reduces our labor costs. Because you can imagine in a building the size of, let's say, the Browning Center, where you have hundreds and hundreds of light fixtures, bulbs are going out all of the time, lamps need to be changed, and we're spending labor dollars to do that could be spent doing other things. You'll notice that the campus standard that we use for light color is very white. It's daylight, also known as 5000K. That's very intentional. And there's a few reasons for that. There's a little bit of energy benefit to it. The human eye can actually see the wavelengths that are in 5000K better than it can some of the more orange or yellow colors of light that you see. So I can use less light to provide the same visual performance. And then there's also some research that shows that 5000K lighting can help improve alertness, help people pay attention in a daylight setting, that kind of thing. So that's very good. The other thing that we do with lighting is how we control it. Our exterior lighting is all controlled by photocell. Standard practice is usually to control it with an equation or some sort of lighting contactor. We found that those systems are a little too complicated for our taste. Basically what happens is this photocell detects the sun that comes up and then turns off the outside lights. Outside, we are 99.9% LED. I'm aware of 2 locations on campus that aren't LED, and it's like 6 fixtures total. We've done all of our street lights, all of our walkways, all of our parking lots, all of our building exteriors. The big spotlight that shines onto the W on the Sky Suites on the football stadium, that's an LED. Inside, I'd say we're about halfway there, and I expect to be finished somewhere in the next 5 to 8 years, depending on how capital funding goes, which, given the current economic downturn, those things can change very rapidly, and it's been interesting to see. Inside, we use what are called motion sensors, vacancy sensors to detect when people leave the space. I actually think they're pretty neat in how they work. You'll see them all over campus once you learn to recognize what they are. And I don't think I have a picture. No, it doesn't look like I have a picture. Anyways, you'll see a little blinking blue and red lights. The blue light is an ultrasonic wave that comes back, and if it detects movement, the blue light flashes. The red light actually measures the temperature of the space, and if there's a change in temperature, it knows that people are moving. So, like I said, all of our new construction, all of our retrofit projects. Did my headphones just die? I am going to end the presentation and make sure I'm still recording. Okay, one of the lighting projects in particular that we were proud of is the D-Event Center. As far as we know, we were the first NCAA Division I basketball arena to go fully LED. LEDs have some other advantages. They turn off and on instantly. They can dim very quickly. They don't make noise. They don't generate as much heat and so on. There's a lot of other things that go into efficiency with regards to building design, sizing fans properly, running those fans properly, controlling their speeds. So efficiency is something that's always at the forefront of my mind. And in general, as a rule, what I like to do is engineer the system so that we kind of can't screw it up, right? We engineer it to be so efficient that regardless of how we're going to operate it, it's still going to be efficient compared to the business as usual case. So to give you an idea of our progress, I mentioned under our baseline we were about 35 million kilowatt hours. Right now we're down to about 27 million kilowatt hours every year. Electrification. Electrification is a very interesting thing. So most of the time, when I tell people I'm electrifying campus, one of the misunderstandings that I come across is how we heat. Okay, because most of the time when you think of electric heat, you think of a space heater, which has a resistance coil, right? It's a wire that electricity does not go through very well, which means it gets hot, and then you blow air over it and you heat the space. That's not what we're doing at all. What we're using is actually technology that everybody here, or nobody's here, I'm in the room alone, most of us are familiar with, and that's the refrigeration cycle. Okay, so if you think about a refrigerator or an air conditioner, what they do at a fundamental level is they use compression and expansion to move energy from one place to another. Now, both air conditioners and refrigerators do so in one direction. The refrigerator takes energy out of your food, basically, puts it into your home. The air conditioner takes the energy in your home and vents it to the outside air. And that's why if an air conditioner is running and you place your hand over it, what you feel is warm. The systems that we use, they're called heat pumps, do that, but they do it in both directions. Okay, so I'm going to go back to this slide. This one. These tunnels contain a water loop that touches every major building on campus. And what the heat pumps do is use that water loop as their energy source or their energy sink. Okay, so in a building like Lindquist Hall, for example, have a water loop in the building. I have a couple dozen heat pumps that are serving the spaces. The heat pumps take energy out of the water, put it into refrigerant that then circulates throughout all the spaces in the buildings. Okay? These can heat and cool simultaneously. We're separating the heating and cooling from the ventilation portion of the building, which means I can downsize my fans drastically. In the library, we went from 250 horsepower fans to 20. These systems have a lot of benefits. Okay, every space gets their own thermostat. They save us money on our energy bills out of the box, right? Even if we weren't one of the leaders in terms of environmental goals, if we didn't have this carbon neutral goal, these systems are still taking hold because they save money over traditional steam-based or hot water-based systems, okay? Better comfort, that comes from the thermostats. Energy sharing, I mentioned this, simultaneously heating and cooling. If one office wants to be hot and one office wants to be cool, they just balance energy, okay? And that happens between rooms in a building, it happens between floors, it happens between different buildings, right? They have a better warranty. That's more for us facilities people. They're quiet. They don't require as much space. And they do not require direct combustion of fossil fuels. Our legacy system on campus, the steam system, requires combustion of natural gas. These do not. Okay? We're looking at electrifying. In fact, I had a discussion this morning on this topic, is how do we electrify our fleet on campus? How do we electrify our landscape equipment? Our buses? You know, we are really pushing on every source of emissions that we have. On the left here, you have an electric Kubota. This is a landscaping vehicle. On the right, you have the 40-volt Cobalt leaf blower. I own one of these, and I absolutely love it for residential use. The commercial ones have more of a backpack. We are electrifying our checkout fleet. We have a number of Chevy Volts and one Chevy Bolt in the fleet. We're looking at, with great interest, the next 2 or 3 years as more work trucks and work vans become available. I lost my train of thought, but that's okay. One other thing that we did is we electrified one of our diesel buses. Basically what we're looking at from again, this is the on-campus transportation element, is starting in 2025. Our goal is to have every new vehicle we purchase be a full EV. That's the goal, because it takes us about 15 years to replace all of our vehicles on a given, on this given maintenance cycle that we have. EVs have come a long way in the past several years. I personally drive a Chevy Volt, which is it's a plug-in hybrid. Um, it has 40 miles on the battery, so most days I don't use any gas, and it has gas as a backup if I need it. The Chevy Bolt pictured right here has 238 miles range. I've taken it to Alta and back and only used like a third of the battery. I was not there skiing; it was for a work event. So this is somewhere that we're pushing very hard. Okay, renewables. This is the third point in the plan, right? So once I've maximized efficiency and I've electrified the end use of that energy, then I need to find a way to renewably source it. Our primary push here, like you see on the left, is going to be solar. Okay. This particular solar array is out at the Davis campus. We have 1.8 megawatts, and it's designed to offset the entire Davis campus's electricity use over the course of a year. Now, these panels are actually owned by Tesla. They're not owned by Weber State. We have what's called a power purchase agreement, which is basically we let them use our land, they build the panels, they own and maintain them, and we buy the power from them instead of from Rocky Mountain Power. On average, we save in the realm of $12,000 to $15,000 a month from these solar panels. The contract lasts for 20 years, and then at the end, we probably buy them. Now, you'll probably note there's not as much solar on the Ogden campus as there is on the Davis campus. The reason for that is economics. The power on the Ogden campus is much cheaper because we maintain a lot of our own electrical infrastructure, and so economically, solar hasn't made quite as much sense, particularly when you compare it to something like efficiency. Now, we do have a few solar arrays on the Ogden campus. There's one on the Union building, there's one on the facilities building, there's one on the public safety building, and I actually, this summer, now we might move the timeline up for that, now that graduation has been postponed, I'm going to be putting in a 500 kilowatt solar covered parking array in the W10 lot. It will remain W, it will not affect parking prices, and everybody who parks in that W lot between public safety and the Institute will have covered parking. My plan is to build one of those every 2 to 3 years to reach our goal. So that's the primary way we will get to carbon neutral after we electrify. Now, we won't be able to completely power the campus from on-campus solar. We'll probably have to do some off-site as well. And there's a number of different forms that can take, and so that kind of remains to be decided. The next piece that, sometimes I did not mean to push that button. The next piece of the renewables is what we call ground source. And on the right here, you can see one of our first ground source fields. So I mentioned the heat pumps. Now, let's say that we're in a winter mode in a building, and the building needs a lot of heat. That means the heat pumps are going to take energy out of the campus water loop and put it into the buildings. Okay. Now, eventually, what that means is that water loop will get cooler and cooler and cooler to the point where the heat pumps won't work anymore. So our goal was to find a heat source for that water that doesn't use fossil fuels, and that's where ground source comes in. So here on the right, you can see in the foreground one of our ground source wells. Basically what this does is we take the water from the main campus loop, we send it deep underground 110 times, depending or more, depending on where it ends up. And because the temperature underneath the earth is constant year-round, it can heat or cool depending on our needs, right? So this particular well, where you see the pipe sticking up out of the ground, is about 270 feet deep. It's about 6 inches wide, and you basically stick some heavy-duty sprinkler pipe all the way down. You have a U-bend at the bottom, comes all the way back up. You fill it with a thermal grout to diffuse the energy really quickly. And like I said, at the W4 lot here, which is next to the football stadium, you have 110 of these wells, and they're 270 feet deep. Okay. We have another ground source field right next to Lindquist Hall underneath the quad. Now, Lindquist Hall has been very interesting because it's isolated from the rest of campus, and it only calls for energy from the campus systems if it needs to. And it's gone the entire winter without needing to do so. It operates completely off that ground source loop. So effectively, once I build that solar covered parking array, Lindquist Hall will become a carbon neutral building, basically overnight once it starts operating. So long term, these are replacing our chillers, these are replacing our boilers, 7 or 8 of these fields, and we will be we'll have all of the heating and cooling that we need. Okay, I took a quick break there to make sure everything's working. Clearly, this is ending up being more than 20 minutes, but hopefully it works. So the fourth piece is the reinvestment piece. And this is another place where Weber State is very unique. We have what's called a revolving green fund. This is basically a line of credit with the administration from which I can borrow money to pay for energy projects, and then I pay that debt off with energy savings. Okay, so originally we looked at what's called an ESCO, which is basically when you have a company come do all this work for you. We couldn't swallow those markups, and so we set up this line of credit instead. So I pay that debt off plus 3% interest, which means the university is actually making better money on its investments in me than it is in the marketplace. Okay. Now, I don't want to talk about this other annual negotiation very much. I just want to drive home the idea that I have a line of credit that can pay for a lighting project, a steam upgrade, a VFD, a solar panel, whatever I deem is necessary. And this is all rooted in the economics of the projects. So I, as the energy manager, have to understand the engineering behind the system, how it operates, the economics behind how utility structures or utility rate structures work, do an analysis. Most of the time it's very quick. I have some rules of thumb that I use. But sometimes I do dive in quite deep to understand how things are working. And as long as the ROI, the return on investment, is better than 3%, that means I'm gaining ground. So I'm going to skip this slide, and this is the one I want to get to. This is a graph of the dollars that we have saved since we started this program. Okay, so you can see at first we were pretty modest. We started out in the $400,000, $500,000 range. You can see the big jump in 2012. That's our steam shutdown. And then you see this kind of tapering off, but gradual increase to the point where we're now saving $2 million a year. And what that means is I have $2 million minus 3% to spend on projects. Now, with particular regards to solar, this has made things much more digestible. Because I've secured this cash flow, I can pay for projects that might have a 40-year simple payback, right? And they're only at a 2.5% ROI. This next year, I'm actually hoping to rocket past 2.1. And given the current state of campus where people aren't in buildings, I should be able to do so quite easily. Now, this has other impacts, right? We've reduced electricity consumption by 30%, natural gas by about 30%, utility costs down 40%. Depending on which scope of emissions you're talking about, we could be down 45%. And these are raw numbers. Okay, I am not normalizing. I am not accounting for growth at all. So during this period, we've increased our square footage by 640,000 square feet. And we've increased our students by about 13,000. I think in fiscal year 2007, we were about 16,000 students, and now we're about 29,000. So this is where it gets impressive. And the great thing about Weber State, and in fact, one of the reasons I came to work here, is I saw, for lack of a better term, the sustainable nature of these finances and these infrastructure improvements. We are electrifying about one building a year. Our current project is Lind Lecture. If we continue at the current pace that we're going, we'll have electrified the entire campus by 2040, 10 years ahead of our goal. Now that gives us plenty of time to figure out our offsets, figure out all of our renewables, and kind of smash that 2050 goal. So here's a graph. I'm a data guy. I'm not an engineer, but I pretend to be. This is a graph of all the different scopes, the different sources of our emissions. And there are some pretty interesting stories here. You can see natural gas decreases. Again, that's primarily due to us electrifying the campus as well as our steam improvements. Fleet stays about the same. Refrigerant pokes its ugly head up from time to time. This is tracking leaks in our systems. Obviously, refrigerants are, well, maybe it's not obvious. Refrigerants are a molecule that is a much more potent greenhouse gas than, say, carbon dioxide or even methane. So it's something we track scrupulously to account for in these kind of analyses. Electricity obviously is down quite a bit. Air travel is an interesting one. You can see kind of this curtailment of all travel with the Great Recession, and then it kind of creeped back up. And I'm actually expecting to see a bit of a dip once we get our 2020 numbers done, or fiscal year 2020 numbers done. This is all fiscal year 2018 data. Solid waste more or less steady. Student commuters more or less steady. What I think is interesting is faculty and staff commuters have decreased quite a bit. Now, we are doing a lot on the transportation front. We offer discounted parking permits if you drive an efficient vehicle. Everybody gets a free UTA Ed Pass. We're installing EV charging stations. How we gather this data is every 3 years we do a commuter survey. But again, my responsibility is primarily the natural gas and the electricity. That's our buildings. So I mentioned this a little bit. I'm not going to touch on it too much. One area we are getting after is water conservation. I have a peer whose job title is Water Conservation Specialist. His job is to make sure we're irrigating well, irrigating evenly, not too much, that we're not getting after leaks and all of these sort of things. We also have a water council, and we're drafting a water plan that's very similar. Very similar to our climate action plan. So you're talking about, monitoring our water use, low flow fixtures, toilets and urinals, smart irrigation, stormwater management, xeriscaping. There's all sorts of things that go into water. We also have a zero waste goal by 2050. We have a zero waste council. Food sustainability we're touching on. I'm breezing through this because it's not really my area of expertise, but I do want you to be aware that we're doing it. I want to spend a minute on this slide. These are the main ways that we engage the campus. We have a very strong green team program. We have about 70, if I recall correctly, green teams that are currently registered. These are faculty and staff who are interested in reducing the environmental impact of their operations. So they sign up, you get t-shirts, you get a plaque, you get certified, you get points for taking different kinds of actions, that sort of thing. The Intermountain Sustainability Summit is something I often plug in these presentations. It was last week. We did it online only, but it was still a neat event. This is an annual thing, so if you're interested, keep an eye out for it in the future. And we have our environmental ambassadors. So this is our student group that does a lot of outreach for students in particular. If you're interested in getting some volunteer hours in, this is where I would suggest you go, and I can get you their contact information. So these are the kind of things the environmental ambassadors do. The Clear the Air Challenge is a contest to see who can reduce the most trips every February. Do tree plantings, green move in, move out, free swaps, that kind of thing. Also, I was wrong. There are now 79 green departments participating, and it has grown very, very quickly over time. I mentioned the summit. One of the other things we're trying to do, because we are a university and we're focused on education and engagement, is taking these ideas of electrification and efficiency into the community, right? So we've done a bunch of community programs with solar, electric vehicles, electric lawnmowers, efficient lighting that are trying to push this out to the community at large, because we really do view our approach as a solution to building and transportation emissions. If we electrify the Wasatch Front, and even if we don't do renewables, okay, if we just electrify our building stock along the Wasatch Front, a good chunk of our air quality problem will go away. It will just go away. And so that's one of the reasons we're pushing this so far. So in 2015, we did a community solar program. We installed 750 kW of solar across the community. Did so at a reduced cost for the customer. Drive Electric Northern Utah was a very similar things. There were 28 EVs that were purchased through this program. Cut Pollution Mow Electric has run twice. 1,250 families exchanged gas mowers for electric mowers, which it was a lot of fun to participate in. I counted. I personally hauled about 90 lawnmowers that day. They weigh about 70 pounds apiece. But it was a fun thing to participate in. And Empower Northern Utah, this is our most recent ones. We distributed over 5,000 LEDs to 392 households, 37% of which were low income. And we estimate that this saves the community about $35,000 in lighting costs every year. This is a project that's going on right now. I like to mention it because it is a student-driven project. There is a thing called the Solar Decathlon, which is a national competition for high efficiency and renewably powered housing. So this home has been designed and for the most part built by students. It's on 28th and Quincy. You can drive by it. It's not occupied yet. We're just wrapping up. It actually looks like a house now. Some of the finish work is going on. But what I think is so neat about this is we're building it, we're going to sell it, and then the proceeds that come from the sale of the home will go to building another home, and we will just keep doing this, right? And so, one of the misconceptions that I come across frequently is that electrified heating and cooling systems are not suitable for our climate. This is not true. This home has a Mitsubishi mini split heat pump, and it has 100% heating capacity, 100% at -5 degrees outside air. Okay, so it can more than handle anything the winter can throw our way. This is a misconception I come across a lot, and from people that should know better. Heat pumps have advanced to the point where they are perfectly acceptable for Utah's climate. I'd put them in Montana, in all honesty. Okay, so with that, this is not my contact information. My email is justinowen@weber.edu. If you're interested in Green Department or the Environmental Ambassadors Program, please reach out to Jennifer Bodine. Her email's there at the top. And then Alice Mulder is the director of Spark. We work closely with her on a lot of initiatives as well. Feel free to reach out to her. Again, my email, if you have any questions, justinowen@weber.edu.